Okay, for the second part, I think we will discuss or I'll give lecture on the concept of the stress, and then stress and the strains. This is on chapter 2, and chapter 3 is on the torsions. Okay, so the books that I use for uh, this second part is on the title is Mechanic of Materials. Okay, fifth editions. The author is Ferdinand P. Obia. Okay, so this one is already shared in the first class, in the first weeks of the class. Okay, so for the chapter one is just introduction, which is a concept of the stress. I think all of you already know how. I think you learn already. Okay, just recall it back what you have learned in static course. Okay, if you still remember during your first year, I think. Okay, you learn this concept of distress. Okay, what a method you have to analyze the what is it? The stress in joint as well as in the sections. Okay, so actually for this chapter we devoted to study about the stress that occurring in many of the elements, okay, contained in such as like construction machine, right? Okay, for example like a excavator. Okay, uh, maybe like a front loader, there's many joints and also members, right? Okay, so these members have two force members. Okay, axles, bolts, and also pins. So we're going to analyze all the force in each of these members, axle, bolts, and also pins. Okay, by using method of joints, method of section, and also we are going to analyze the what is it, the axial loading or and also normal stress. Okay. Uh, let's we continue. Okay. So for this chapter, okay. First is I think I'm gonna give a short review the method of the statics. Okay, and then stress in the members of the structure, analyze and designs. Normal stress and shearing stress lah. Okay, this one I'm not sure during your statics class you learn or not about the axial loading and also shearing stress. Okay. So I hope that you can define the concept of normal and shearing stress. Okay, and you can do the analysis by using a method of joint and also method of sections. Okay, so the main objective of this course or this study is to provide the future engineer with the means of analyzing and designing various machine and loads bearing structure. So we can see in our daily life how to about the machines and also load bearing structure like a truss. Okay, what else? Yeah, for the machines. Okay, in chapter 3 also you're going to learn about the torsion, this twist, right? So all those things you can find just maybe next to you, or maybe when you ride a car you can see that. Okay, both of the analysis and design of the given structure involve the determination of stress and deformations. Okay, so when you give a load, okay, of course this deformation or deflections occur. So how can we analyze this deformation? Okay. Okay, so many machines elements are pin connected in order to enable free rotation and their connections. If you look at here on the right side, this is I think is what is this? Excavator front loader, I think, and the left side is truss. Okay, this pin support exert a force on each members, but no moment. Okay, if including moment, we also going to calculate the moment. Okay, how to calculate? Okay, moments. Okay, force times with the distance. Okay, so the application, if you look at here, that there's a support a roof. Okay, of course we can determine or we can analyze. Okay, this the force between the members in the roof or the truss. For a given truss geometry and loads, how can we determine the forces in the truss members and select their size? What is the correct size? Okay, how the weight or the load that we can introduced to the truss, so that is not gonna be fail lah, this truss. Okay, what is the maximum load, right? We can apply. Okay, all these things we will analyze. A more challenging question is that for given load, how can we design the truss geometry to minimize the cost? Okay, so engineer, of course, cost is one of the important uh, criteria that you have to consider in designing not only the truss but as a chemical engineer like reactor or distillation column. Okay, all those things is a cost because we want to uh, uh, what is it? We want to earn something, right? Okay. Okay, truss also, are also used in a variety of structure like cranes or frames or aircraft or space stations. Okay, of course for the house. So how can we design the lightweight of the structure? Okay, that will meet load, safety, and also cost specification. Okay, so just recall back about the prefix. Okay, what we're gonna learn is about maybe a prefix and unit. I don't think I'm gonna explain. Okay, type of support rations you already learned in the static course. Okay, force resolutions Fx Fy so that we can get total force. Okay. Moment of a force, free body diagrams, right? Method of joints. Okay, before you start the calculations or to determine force for each members, we have to draw the free body diagram. Okay, for those who not draw the free body diagram, I just give you 0 for all your answer. Okay, because you have no sketch on the free body diagram. Okay, free body diagram is important. Okay, method of sections. Okay, this is additional method. You can use combine method of join and also method of section. Okay, to determine the force in the members. Okay, in each members of the truss. Internal force in the structure members, normal stress, shearing stress, and also a deformation. I think is chapter 2. Okay, we will calculate in the chapter 2. I think. Okay, stress and strains, as well as the some examples that maybe is already provided the uh, what is it, the answer, also the solutions. So we will discuss some of the examples and the rest you can read by yourself. Okay. Okay, prefix used in engineering. So I hope that you can you're familiar with this one. Okay, giga, mega, kilo, milli, micro, nano. So this one is I don't think. So you have to know how to convert from the US unit to the SI units. Okay, so I think you use not only in the statics, material engineering, but also in mass and energy balance. I think you're familiar with these units, right? Okay, the units of course P is axial load, A is the cross sectional area. Okay, sigma normal stress. Okay, that is the normal the general unit that we use. Okay, SI unit of course for load newtons. Okay, A is square meter and Pascal for the normal stress. While as US units, right? Okay, kilopascal, inch, square inch, PSI. Okay, so, okay, just how to convert. If you don't know, you can uh, refer to the Googles or any books how to convert this one. Okay, so these are the types of the support operations. You have to know how to use this one, okay? Especially if there's a roller here. Okay, what is the type of the support operations? Okay, and this one in terms of the cables. Okay, only one direct. Yeah, and this one is smooth support. This one. This one of course they have a tool. Any direction actually is okay. Okay, but we will how to say correct the what is it the support reactions when we do the calculation if you get the negative value. Okay, similarly this one also, and this one of course there is a moment because this is a fixed support. Okay. Okay, how to resolve the force and how to add the force. Okay, I think you're familiar with this one, right? Okay, how to resolve the force to Fx and Fy. Okay, so if you look at here that this one, Okay, this one is f1x, right? This one is f1y lah. Okay, if you look at that. Okay, so if you look at here, there's a times, right? Okay, so meaning that should be f1x times with the cos 30 degree lah. Okay, and fy this one in 3 degree. Okay, okay, so for 400, if you look at here, this one, right? Instead of the angle is here, the value of the angle is here, so you put here. Okay, so it should be opposite. Okay, so if you look at here that, okay, so for f to x, so if you resolve this direction and to this direction, okay, this one negative, opposite of the x axis, right? F to x, okay, one f to y lah. Okay, so this one, since they given the angles here 45, so it should be seen 45. This one is cos 45. Okay, okay, so if you want to add the components, okay, we can get this one. Okay, summation lah. Generally we use this one, summation. Okay, so if summations we use, so we define to the right side summations f, okay, and to the top total f positive. Since this is based general definition for the vector, okay, right side and to the top is going to be positive. Okay, so you just add lah for both the 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 force that you resolve. Okay, this one. Okay, just to the x direction and y direction. Okay, so is it clear this one, the how to resolve the force? Okay, it's just like recall back what you have learned in the starting. Okay, for the moment is force about a point provide a measure of the tendency for the rotation. It's called all the torsions. Okay, so if you look at here how to calculate the moment is just remember this one, it should be m naught equal to f times d. Okay, it should be perpendicular here, should be 90 degree. Okay, if not you cannot calculate the moment. Okay, the distance is perpendicular. Okay, d is the perpendicular distance from point O to the line of action of the force. Please remember perpendicular 90 degree. The direction of m is either clockwise or counterclockwise. Okay, either this one or this one. Okay, clockwise is direction, right? Okay, so please remember. So generally I think we define total moment. This one is positive lah, clockwise equal to 0. If that is depending on your definition actually. Okay, so for example, this one, 400 force is applied to frame and theta is equal to 20. If you look at here that this is a 20 degree. Okay, find the moment of a force at A. What you have to do is you have to resolve this force, right? So when you resolve, okay, so you can get a negative fx and this one is negative fy, right? Hey, negative fx. Oh shit. Okay, to the side. So theta is going to be here. Okay. So you resolve, right? So if you look at here that this one is negative f y negative f fx. Okay. So once you, if you want to calculate the, what is it? the moment, right? So if you look at here that this one for the fx, okay, and also for the y, right? Okay, this one is y. So this is the distance. Perpendicular, right? 90 degree. This one is also the distance. 90 degree. Right? So this point A. Okay. So we can call it fx and also fy lah. So if you look at here that once we resolve the given force to x and y components, okay, we can calculate the MA. So the total moments, if you look at here that this one, right? Because this one is like to this side. This one is to the counterclockwise lah, same to the counterclockwise. So we define clockwise as a positive. So negative 400, negative 400. So we can get negative 1160 because our definition is clockwise is a positive, but we get negative, meaning that is a counterclockwise. So to this side lah. Okay. Okay. So anything if you want to start, you have to draw free body diagram. That is the first thing. Okay, for those who will not draw the first body diagrams, just give you a 0. Okay. Sekejap eh. Okay. How to draw the free body diagram? If you look at here that then for focus should times 3. Should times 3. Why should times 3? Yeah lah. Okay, for this one, okay. So this is a distance is a negative times with the 3 lah. Okay. And this one is time with 2. Eh? Okay. Okay, so how to draw the free body diagram? Okay. If you look at here that you have to draw the outline shape. Okay. And then show all the external force and the moment. Typically, this include apply force and also weight of the body lah. So if you look at here that if we include weights, of course at the center generally for this one, because it is a how to say linear. Is it linear? Okay, the same lah at the middle lah, center of the gravity lah here. Okay, and label load dimensions also including unknown force, a couple of moments. Okay, if you look at here, this is a fixed support. If fixed support, you have to refer this one again. Okay, you have to refer this one for the fixed support, right? Okay, how to draw the support reactions. Okay, so if you look at here that this one, right? Okay, since there is a moment, okay, fixed support should be this one. Okay, so you just denote as AY and AX, right? And then at the center of the gravity, this ones, it should be W. Okay, time with the G lah, because we want to convert with the G. The symbol of gravity is big G or small g. I forgot. Okay, the gravity. Okay, this is 1,200, right? So this is the for me the full free body diagram. Okay, so you have to delete this one. Okay, so this is I think so you still remember this one. Okay, complete free body diagram. Okay, including the distance. You have to put this one fixed support. Okay. Okay, oh G, big G. Okay. 100 times with the weight of the beam is 100, so times with G is equal to 918, 81. Okay, so let's analyze the beams or the truss, okay, by using a method of joints. Method of joints, I think we have to detach all the members and we analyze the force at each joint, a pins, okay, at the pins or the bolts lah. So how's the procedure? If you look at here, that method of joints, there's no procedure. Oh, I think this one terbalik. Okay. So procedure of the analysis, you first, of course, you have to draw the free body diagrams. We want to know to one unknown or two unknowns. All unknowns is we have to know, okay, because it's more unknowns, it's difficult to solve. Also, we have to use another method such as method of joint and method of sections, or we have to use a trigonometry methods. Well, that one is you learn instead. Okay, find the external reaction and the truss support, determine the correct sense of the member, whether to the left side. Okay, is it a clockwise or counterclockwise? It's just a correct sense. Okay, if it's not correct, you can revise the direction or the vectors after you find the value. If a negative, so meaning that is the opposite direction. Okay, orients the x and y axis, apply a summation of fx and total fy's. So we call it this one equation of equilibriums actually. Okay, equation EOE. Okay, so use known force to analyze unknown force. Okay, so make sure that unknown force is not too many. Okay, if not you cannot solve uh, your problems. Okay, so method of joints. Okay, so this is the kenapa ada kat sini? It should be here. Okay, okay lah, betul lah sepatutnya kat sini. Okay, saya rasa lah. Tapi I think it's just it's okay. 545. Ada susunan ni. I think this one. Oh, betul. Okay. So determine the reaction A and C and the force in each member of the truss and indicate whether the members are in tension or compression. Okay, if you look at it, how can we use the method of joints? Here, joint B, joint A, joint C. So please remember they have a support reaction here. Okay, so this one I think uh, this one we can consider as a point. C, I think is more to like a roller. This one, okay, this one is roller. Okay, this is a roller. AY. Okay, and then A, they have a what we call it here, external pin, right? So if external pins, just based on the yeah, AY, AX, external pin. So you refer back the support reactions table. Okay. Okay. So since you have to do the free body diagram first. Okay. So if you look at here that this is a free body diagram. If you want to do the whole free body diagram also, uh, uh, for me, I would like to suggest you to do the whole free body diagram rather than joint by joint first. Okay, joint by joint also possible. So if you look at here that if you do free body diagram, I think it's not in my PowerPoint slide. I think I'm not included. I think let me check. Okay, so if you look at here, all right. Okay, if we want to draw the free body diagram. Okay, so you just draw lah. Okay, point A, point B, and this one is point C, 45. This is moving. point B, okay, 500 Newton. This one C, right? CY. This one is the whole free body diagram. So that you can predict which one is you can solve with there's some unknowns and the number you can know the number of unknowns and also known and unknowns. This one force. Okay. So this one AY and AX. Okay. Okay. So this is the whole free body diagram. Okay, and the distance. If you look at here, there's a distance, right? Okay, 2 meter, and also 2 meter. Okay, so that is the whole free body diagram. Okay, and we know maybe we can start from B lah. Okay, we can start from B. Yeah. Okay, because they have a one unknown, two unknowns, right? Because this one is unknown, unknown, unknown. This one unknown, 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 unknown. Four unknowns. This one is two unknown, one unknowns. Okay. So if you look at back the procedure for the analysis, draw free body diagram, at least one known and two unknown forces. Okay. So you have to remember that. At least. Okay. So meaning that we can start from B. Okay, start with the joint B. So if you look at here, yes, for the truss, we need to know the force in each member, because member are internal force. Okay, for the external force, apply equation of equilibrium. This one. Okay. So we start with the point B. Okay. So just make the sense. Once you pull this ones, I think this one is going to be become a tensions, and this one is going to be like is press. It's like a press. So when it's a press, this one, the members is press, so it's going to be opposite this one. So that's why it's opposite, because this one you pull, right? Once you pull, this one is become tension. Okay. Okay, so this member is become tension, and this one is opposite. The joint is going to opposite. This one is become uh because you push, right? Push, and this one is going to be opposite to the pin direction. Okay, direction of the pin for FBC and FA. Okay. So similarly, you have to draw the free body diagram based on your sense. Okay, the correct sense. Okay, this one to this direction. So just denote FBA, FBC, and 500 newtons at the point B. So use the total Fx and total Fy, which is equation of the curve. Okay. So since we define to the right direction is total Fx is positive. Okay, so just add 500 minus because this one, right? If you look at here that, so you have to resolve to this side. Okay. Right, FB. Okay, so meaning that this one 45 degree. So this one FBC, okay, so FBC is in 45 because the degree here. Okay, negative, negative FBC. Okay. Okay, so we can get FBCX this one FBC, this one FBCY, BCY. So meaning that negative FBC sin for 45. Okay, so just resolve for FBC and then you do for Y direction total Fy. So we have this one FBCY, right? FBCY cos 45 5. So minus with this one because it's negative. So we can get 500 Newton. So intention compression, meaning that this is correct lah, correct sense. So positive. And then this one is positive also. Okay, 500 Newton. Okay. So after you solve joint B, so you can get the for this point C. Since for joint B, if you still remember, FBC is to this directions. Okay. So for the joint C, it should be opposite lah. This directions. This is FBC lah. Right. And this one. So use solve for the point C. So similarly, also total FX we define negative FCA. Where is the FCA? Okay. So meaning that we have to resolve this one. FBC. Is no need, I think. Oh, yes. Okay, this one FBC lah. Okay, negative FBCY. And this is a angle 5 degree. So see to the right direction, FCY because FCA is to the left, negative FCA to the right side times with the 44 cos 45 because your angle is here, not here. Okay, so equal to 0. So we can get FCA. And then we can calculate to the y direction to get the CY. Okay, so that we can get the CY is 500 newtons. We determines already FBA and FCA. Okay, you still remember FBA because it's intention. It should be opposite directions. Okay, so 500. Similarly, you solve. This one is no need to resolve, right? It's already X and Y direction, right? So you can get all the value. So this is the method of join. Okay, so as a summary for the method of joins, FBD for the pin shows all the connected members and external force applied to the pin. Okay, so if you look at here, FBD of the member shows only the effect of the end pins. Yeah, here. Not at the middle, this one, only at the pin. This one we have to use the method of join and method of section. Okay, so all this one, see? Please remember this one for each point, each pin, if this direction, so for the member it should be opposite similarly also. Because it should be when we add these two, it should be what we call it, not neutrals, is become zero lah. It's cancel each other. It cancel each other. Okay. Okay. So can you do this one? Tutorial one. I give you about 5 minutes. Tutorial ones. Please solve these ones and give me the answer. Okay, what you have to do is draw free body diagrams. Okay, how you draw the free body diagrams? Okay, I want to share the Jamboard. Please do. Jamboard. Take one paper. Okay. Take one SKTK2243. Yeah, I hope that you can see this one. Page. Page 14. Draw free body diagram and solve it by using what is it? Equation of equilibriums. You already learned in this one, right? In the static. That is the link. Please go. Please use this link. Okay, I want to see. How do you draw the free body diagram? Take picture and post it here. Anyone? Yes, there's a free body diagram. Okay, good. So can you solve? Okay, please solve. Okay, so let's see this one. Okay, one example. It's a free body diagram. Why you didn't draw this one? I think this one is wrong. Okay, so you should redraw again. Okay, redraw. So you should redraw. So then is this one. Should redraw lah. This one we have to remove. We have to remove like this one. Okay. Okay, but this one is have no support reactions. The correct free body diagram and check. This one is okay. Maybe you just use a AX lah, AY lah. Okay, not FX, YFX. Okay, this one also right. Okay, should be okay. This one without the what is it, the pin or the joint. Okay, this one is okay. BX, BY, BY, YX. This one. This is wrong. And this one is okay. That's okay, but you can resolve the body diagram like this one. Okay, this one okay, okay. This one is, I think, is a pin. This one. So just one. This one on it. This one on it. Okay, only one. Okay, this one is not correct because there is a pin there. Unless this one. This one you have to support action. Okay. Check. Oh my. What's wrong? Oh. Okay. Okay. So let's we yeah. How to solve? Mana besarkan? Almost finish. Yes, BX, this one is correct. BX is correct. AY is 331. Okay, almost. BY, can you check this again? Yeah, I think the method is correct. Okay. This one is correct. Okay. So let's me right here. So if you look at here that you have to redraw again. Okay. This one 600 newtons, 200 newtons. Okay, and this one is only AY. This one is 100 newtons. Okay, what else? B. So we just BX, BY. Okay. And then the distance lah. It should be a little bit here, I think. Okay. So the distance. Label. Okay, what else? This one also. All this one you have to label. This one, this one, this one, this one. Okay. Okay. There's a free body diagram. Okay, from this all the free body diagram. Wait, so let's recalculate. So we start with the total FX. Okay, positive. That direction. Okay, 0. 600 cos 45 bx equal to, okay, bx equal to 424. Okay, and then at point B, we do the moment. Okay, total moment. Definition counterclockwise as a positive. Yes, counterclockwise positive. So 100 times 2 meter times 600 sin 45 times 5 meter. Okay, minus 600 cos 45 times 0.2 meter. Okay, because there is a distance here. Okay, okay, minus ay, okay, times 7 meter lah. Go to 0. So ay equal to 319 Newton. Okay, and last ones, we have last. Okay, let's ask ay since total F1 positive. Okay, we 319 newtons minus 600 sin 45 100 newton. Okay, right, and then plus 200 newton. Okay, plus by lah, because they have to support equal to 0, so you can get by or 0.5. Okay, that's the answer. Okay, that's all. Is it clear before we stop? Okay, so please do this tutorial too. Okay, and we will discuss in the next class, and we will finish in the next class tomorrow. Until this one lah, as you're loading. Okay, so we just finished within 1 week. Because you already this one, right? You learn this one. Just call it back. What have you learned in study? Okay, any questions? Doctor can share slide. Okay. After this I will share the slide. Okay, that's all. Thank you very much. Okay.